Okay, for these top three, let's do the last one. Let's do the FOIL where we're being asked to multiply things that have an I. So we're going to start by just treating it like a variable. So 2i times 4 makes 8i. 2i times I makes 2i squared. Negative 3 times 4 is negative 12. And then negative 3 times I. Then we're going to combine like terms and we're going to apply the rule of I squared. Do you remember it? I squared is equal to negative 1. And so when I do this first part, 8 minus 3 makes 5i. And then we're going to plug in a negative 1 for I squared. 2 times negative 1 makes negative 2. And so we have 5i minus 14. How'd you do? This one is multiplying using our FOIL method or distribution method, but then you have to apply that rule of I squared being negative 1. This is called a complex number here at the end because it has both a real, the negative 14, and an imaginary part. And so that's just like a quick review of, hey, don't forget about these i's. These other two can be done as your choice of method. I'm going to first show you Tehani's style and then Tia's method. Tehani's style is using a fractional exponent. So we take the 27 and we convert it into a power of 3. So 3 times 3 times 3 makes 27. Negative 3 times negative 3 times negative 3 makes negative 27, right? So we're going to convert that into a base with a power. And then the x to the 6th stays x to the 6th. And then we're going to apply this 2/3, like showering the power to both of it. So we're multiplying out the 2/3 and the 2/3, and then those powers just multiply. In this first one, the 3 and the 3, that denominator cross out, and it leaves us negative 3 squared. And then here, 3 goes into 6 2 times. 2 times 2 is 4. So we're left with a final answer of 9x to the 4th. So that was Tehani's style where we use fractional exponents. How'd you do? Now this next one, I want to remind you about doing fifth root. Anything that's to the power of something can be converted to a fifth root. So if that seems easier for you to do, feel free to do it that way. 32 could be rewritten as 2 to the 5th. A to the negative 29th, we're just going to leave alone for a second. B to the 15th, we're just going to leave alone for a second. Then we're going to apply this negative 1/5 power to everything. So times negative 1/5 times negative 1/5 times negative 1/5. So the first one becomes where the 5's cross out. It just becomes 2 to the negative 1. 29 divided by 5 is not going to work out evenly, so we're just going to leave this as 29 over 5 for a second. We'll talk about that. And then 15 and 5, that can go in evenly, so we're going to say b to the negative 3. Now, do you remember what the negative power does to everything? It's going to put things all in the denominator, right? So 2 to the negative 1 is going to end up putting the 2 downstairs. B to the negative 3, oh, I'm sorry. There was already a negative with the 29 power. So this is going to become a positive 29/5 here, not negative. Sorry, just fixing that one error. Negative times negative made positive right there. Anyways, back to the b. B to the negative 3 is going to also then move down. So that just leaves this a to the 29/5 as our numerator. Well, 5 goes into 29 5 times, but it leaves a remainder of 4, right? 5 goes into 29 5 times, but it leaves a remainder of 4. So that remainder of 4 is going to stay inside a to the power of 4. And when we put it back in the radical, remember it's a fifth root. So fifth root of a to the 4th stays inside, and a to the 5th comes out because that divided evenly. Let me put this nice in the front so it looks separate. All right, so this simplifying radicals stuff here, simplifying fractional exponents, is just a reminder from semester 1 Okay, number 7 has some quadrilateral properties. Just also a quick reminder that only having one set of parallel sides, the maximum you can say that is a trapezoid. You probably think of a trapezoid as looking more like this with the one set of parallel sides, but just keep in mind that no matter what the shape looks like, the definition is that one set of parallel sides just means trapezoid. 4 congruent sides, that's the definition of rhombus. Diagonals that bisect each other, that only occurs in parallelograms. One pair of parallel sides and right angles equals a rectangle. So see if you got those right. Next, we're going to be doing inverse. I'm going to show you the table method. X, if I plugged in a number right here for X, like a 0 or a 1, what would happen to X first is we would be minusing 50 from it. Then we would be multiplying by negative 1 over 98. Then we would be adding 222. We're now going to undo all those operations in order to build our new function with X down here. So here I go in reverse, adding 222. The opposite is subtracting 222. So there I go. Multiplying by negative 1 over 98 means the opposite would be multiplying by negative 98. And finally, subtracting 50 means I'm going to add 50 onto the end. So let's go do our common sense check. Minusing 50 became plus 50. Plus 222 became minus 222. And this flipped. All right, does that make sense? That's our inverse. Now, what if you want to follow the steps that we practiced, the full work, algebraically? You would do step 1, write it with a y in there. Step 2, switch x and y. Step 3, solve. Here we get our x minus 222. Here's where we would be multiplying by the negative 98 to both sides to get rid of that. And finally, here's where we would be adding the 50. So the final answer would still come out to what we have here below that we got from the table method. Okay, so that's determining an inverse either with the table method or algebraically. The second thing you have to be able to do is this graph. So 0, negative 6. I'm going to put that point first. Then I'm going to go up and find a corner. So it looks like 5, negative 1, 2, 3, 4. I'm finding points along my original function, negative 2, 0. And then I just take those points and flip those points, definition of inverse, switch x and y. So this becomes 0, negative 2. Notice the signs do not change. Signs stay the same, x and y just switch. So I'm going to go put a dot at 0, negative 2, negative 6, 0, and then negative 4, 5. And then you just connect those. Make sure to put the arrows to infinity. Now, what's the last thing we need on our graph for full credit? You need that line of reflection drawn in through 0, 0, 1, 1, negative 1, 1, etc. And so don't forget to put that line of reflection straight through the middle and to label all your parts. So I'm going to call this the line of reflection through y equals x. Here's my original function f of x, and here's my new function Oh, just kidding. That doesn't, it looks kind of like it could go to both. So let me make sure to make this clear. Here's my original function, f of x. And then here's my new function, f of negative 1 of x. So this guy is this. And this guy, the original, is that. Okay? Okay, are you going to remember to pick 3 points and flip 3 points? Okay, the final review topic coming up is when we want you to demonstrate completing the square and quadratic formula still for solving quadratics. So the first one, I'm going to, as always, move that x to the left. Here I'm going to divide out of 4 coefficients so I can complete 1 square at a time. So 4 goes into 4, leaves me x squared. 4 goes into 32, leaves me an 8x in the middle. And then we bump that 96 over, making space. We then go do the b work on the 8. So 8 divided by 2 is 4. 4 squared is 16. So I add 16 and minus 16 to both sides. Why is there a 4 right there? Because this 4 is technically distributing with that 16, so it's technically a 64. So we're going to be minusing 16 4 times, or also minusing 64. So 4 quantity x plus 4 squared, there's my perfect square factors from this. And we're going to get 96 minus 64 at the end. All right, 96 minus 64 is 32. So I'm going to minus 32 from both sides. And then I'm going to divide by 4. And I get negative 8 is equal to x plus 4 squared. Now we were trying to isolate these so that we could take the square root of both sides. And that's going to leave me, I'm going to flip this around, x plus 4 equals the square root of negative 8. Well, the square root of negative 8 breaks up into negative 1 times 2 times 2 times 2. A 2 comes out, an I comes out, a 2 stays in. So we're going to say plus or minus 2I root 2 for that root negative 8. Final answer, negative 4 plus or minus 2I root 2. And those are called no real roots, or 2 complex roots, or 2 imaginary roots. So that was showing me that you can do complete the square with a coefficient greater than 1. Here comes quadratic formula. For me to use the quadratic formula, I need it to be equal to 0 as well to get ABC. So I'm going to rewrite this in standard form by moving the 20x over. Now it's equal to 0. Now we can get ABC. A is 5, B is 20, and C is 12. And here we go plugging in. Negative b plus or minus square root b squared minus 4 times a times c all over 2a. 400 minus, that's 20 times 12, is that 240? All right, in the front, negative 20 divided by 10, that's going to simplify down. And then 400 minus 240 gives us 160. So let's break down that 160. So 160 could be known as 16 times 10, or 4 root 10. 10 can't break down any further. And so if we turn this into 4 root 10 over 10, the 4 and the 10 can reduce down to 2/5. So that's like saying 2 goes into 10 5 times, and 2 goes into 4 2 times. And here's my final answer. So This is known as an irrational answer because the root 10 is in there. So I've got two irrational roots. Okay, so notice how complex the solving quadratics are at this point. We're ending the year here shortly, and we need to be very solid on completing the square or quadratic formula no matter how it's given to us. All right?